I'm back. This is the last video of the procedural planet materials tutorial. In the last video I went over how to make a terrestrial planet material that you can use to do some pretty cool looking planets from space. And today I'm going to demo the gas planet material, which is actually kind of a bonus because it's way easier than the other planet material. If you can do the other one, you'll definitely be able to do this one. So that's what it looks like, and let's just talk about how you rig it up. Similar to the other planets, we have a black body sphere on the inside. So let's take a look at where that is. So this is our gas layer, and this is our black body layer. Because this is a translucent material now rather than a non-translucent material, you definitely need the black body layer on the inside, because we can take a look at what happens to the shadow on the planet if we turn it off. You can see right through the planet, right? Like, you can see the rings through it, you can see everything. So what this is doing is basically giving us that opaqueness, while still allowing us to have like the nice soft edge and kind of the fluffy looking appearance of the gas giant. So what do you do to set this up? Well, as far as meshes, you're going to need, you're going to need an atmosphere layer. You don't need a cloud layer. I don't know why this is still here. I could delete this. Doesn't matter. You need your planet layer. Let's rename this while we're at it. Edit, rename. We'll call this black body. You need your black body layer. This uses the texture that we set up in the last one. It's just a literal black texture. It looks like this. You take a material, you change it to unlit, and then you save it. That's it. That's all you got to do. Let's see. Here's our. You have another layer that's slightly bigger than your black body layer. That's going to take your planet texture. You can play with these scales, but usually it's just a shade bigger. You have a plane for potential rings if you want them. And then what is this last sphere? To figure out what this is. Oh, did I have... Well, that's actually a mistake. Is there a master opacity here? No, but master brightness will kind of fit the bill. Maybe I should have figured this out beforehand, eh? I don't think I demoed the actual material instance, what it looks like in the end. You basically have noise animation speed here, which is your distortion noise 1, your distortion noise 2, and your distortion and your regular noise, along with your time divisor. This controls the overall speed of the animation. These control the direction of your individual layers in the noise. You have your noise offsets. These allow you to randomize your noise on the X, Y, and Z axes. You have a brightness and saturate function. You have your distortion scalars that scale the amount of distortion that's applied, and you have your distortion amount values. These scale the amount of distortion that you're going to see. Usually something in the like 0.2 range looks pretty good. You have your distortion scales. These control the size of your distortion noises. So changing these changes the scale of your individual distortions in the material, right? So let's do like 50, 25, I think is what it was on. Maybe like 150. All right, 50. In this one, we have filter width. This controls the smoothness of your blend here. So as I do this, there's less variance, and also like the edges become smoother. We'll leave that at 0 for now, or like a 0.5. Let's leave it at 0. And then you have this flattened Z field. What this does is basically squishes the noise down along the Z-axis so that you get the bands rather than clouds. So if I reverted this all the way back to 1, the texture would probably start looking pretty familiar because it's similar to what our regular planets are getting, except it's animated. But if I crank it up to like 100, we get way too many bands. But basically you can use this to squish the noise texture along the Z-axis and get these nice bands. Then you have your flip values. These will flip the underlying distortions or the master noise. So if I take this, if I turn this on and I flip this to 1, all the colors are going to flip their locations, right? You have your noise scale. This is the size of the master noise that's being distorted. Something between like 1 and 200 is usually pretty good. These values you probably won't want to mess with too much, but they control your. Here, I'll show you. So like the higher this number is, the closer the material gets to the actual boundary of the object. It was on like 5 or 6. And then the higher this number is, the more blurred the edge. So let's go to like an 8. All right, great. You have the same switches that I had on the other planet for flipping distortion types, although these are probably not necessary with this. And then you have 3 color values that determine the color your planet's going to be. If I change this to blue, now I have a blue gas giant, right? If I change this to green, now I have a blue and green gas giant. Alright, so that's how these work. As far as like using the material instance, because I don't think I reviewed that one. So let's go take a look at the material. So if you go look at the other videos, you should have all the other materials you'll need. I've got a video on the ring, the atmosphere. Wait, atmosphere's off. Oh, that's the wrong one. There's my gas giant. Damn it. The atmosphere's off right now. We turn that on as well to get some more edge fidelity and some additional like color variance here. And let's just take it to like a more green blue. I'm on the wrong one. Shit. So we'll go in here and we'll take this to like a color. If we're gonna do green and blue, let's do like a green outer layer and maybe like a blue inner layer. Alright. And now you get this kind of nice green edge on everything, along with the atmospheric highlighting. Master opacity 0.5. Color balance 6. 1. I think this blue might actually just be fading out. Let's go full green with it. Orange. That looks good. All right. So yeah. So in the previous ones, we made the atmosphere texture. I just showed how to make the black body texture. The planet texture here is what we're going to be going over in the tutorial, and I've shown how to make the ring texture in another tutorial. So let's get right to it and start taking a look at our gas planet material. That's the material instance. Here's the material. Okay, so one thing you'll probably notice if you did the other tutorial on how to make the terrestrial planets, let's go ahead and open that side by side with this one. So procedural planet, empty terrestrial planet. So one thing you're going to notice, if we take a look specifically at this area right here, is that it looks an awful lot like this. And that's because it is an awful lot like this. You can literally copy this whole block and paste it in this texture, and this is the majority of the work of actually doing the texture. The only difference here is that I've actually taken the time to create double vector parameters for all the parameters here, and I didn't update the gas to also do that. So they're all in scalar parameters still. So let's take a look at the differences here first. You want your base texture coordinate. You're going to create local position. You're going to create a breakout float 3 components node connected to it. You're going to create a scalar parameter called flatten z, and you're going to multiply the B channel, or the Z channel, by the flatten z here, and then you're going to plug it into a make float 3 with the X and Y channels untouched. Then you're going to create a double vector parameter called noise offsets, and let's go ahead and update this to be consistent. Noise offsets XYZ. You're going to use these first 3 values, and you're going to do a make float 3 from these 3 values. Then you're going to add that to the output of your make float 3 up here, and this becomes your baseline texture coordinate that you're going to use for everything else. Next, under here, you're going to create another double vector parameter. This will be the animation speed along the x-axis of the distortion noise, both distortion noises, the noise, and the time scalar. So first thing you can do is create a time node, connect it to a divide node, and then divide that by your t value here. And that's going to become your baseline time for all your animations. Next, you're going to take your x value, or your d1 value right here, which corresponds to the x, or the red channel, and you're going to multiply that by this divided time number. Next, you're going to take your d2 value, and you're going to multiply that by your divided number. Finally, you're going to take your n value, which is your noise animation speed, and you're going to multiply that by the number. Then you're going to make 3 float 3s from that, plugging the output of this of the first multiply node into the x field of this float 3, and then setting the other 2 values to 0. Taking the multiply of this one into the x field of this one, you might notice a pattern forming here, and then plug both these into 0. And then multiply the last one, or your last multiply will plug into the x value, and then 2 values to just a constant 0 value. And these 3 values are going to become what causes the animation in the clouds of the texture. So over here, you can basically copy and paste the noise logic from right here. You'll have to disconnect this node, which is your coordinate node. You would want to bring these 2 parameters over right here, along with all of this from the texture node, but we'll go over it anyway. So we take our texture coordinate here, and we're going to run it into a divide node, and we divide it by the distortion scale 1. Then we're going to run it into an add node, and we're going to add the output of our D1 multiplied stack of things, which came into this make float 3. We're going to add that to the output of this divide node, and then we're going to feed that into both our noises, which is a texture based gradient 6. Set these to 6. 10 is probably too much. You could experiment with going lower. This will speed up the texture a little bit. These are all updates I made in the other texture and just didn't propagate over. Okay, looks great. So you'll plug the added value into your noise here and the other one into your noise here. You'll create a static switch parameter, feed your top noise into the true and your bottom noise into the false, and then create a static Boolean parameter and plug that into the value of the switch. Finally, we plug the output of the switch into a multiply by -1 mode for the textures, for the noises that are set to -1 to 1. Again, like the other texture, we have to multiply by -1. For the ones that are between 0 and 1, we have to do a 1 minus. So we plug the output of this switch into a multiply by -1. We plug that into the top node of the warp. We plug the output of the switch into the bottom node, into the B node of the warp. And then we go to this alpha channel value and we connect this to a flip distortion 1 scalar value. You could also create double vector parameters to hold multiple of these values at the same time. I just haven't done it for this one yet. The output of this warp is going to go into a multiply node where you multiply it by the distortion amount 1 scalar parameter. So you have to create a scalar parameter for distortion amount 1. Currently I have it set to 0.1 by default. You could do 0.1 or 0.2 usually are good defaults. So you plug that into the multiply node from the output of your warp here, and then you're going to, so there are a couple of subtle differences in these from the other one that you'll have to change. So let's go to the next one. So now, oh, the other thing I forgot to mention, because gas clouds are smoother, we actually have the ability to add a filter width here. Literally all you do, this is wrong, literally all you do is just go in, connect this, create a scalar parameter called filter width, and connect it to every filter width input of every noise in this stack of things. So, just like distortion scale 1, distortion 1 noise type, distortion amount 2, just flip distortion, or distortion amount 1, flip distortion 1, you're going to need a distortion scale 2, a distortion noise 2 type, distortion amount 2, and a flip distortion 2. You need the same exact stuff that you had up here, just increment the number. You're going to run your location, your master texture position here into a divide node, divide it by distortion scale 2. Then you're going to run it into an add node and add the result of the noise above it, the output of this multiply. Then you're going to run it into one more add node, which is where we kind of diverge from the last texture, and to this add node we're going to connect it to our second make float 3 down here in our x-axis animation speed block. So we connect this here, then this value going to go into the position of both of your noises, gradient texture based Voronoi, go into the true and false nodes of a static switch parameter, whose value is connected to your distortion noise 2 type. The output of the switch parameter is going to be multiplied by -1 and feed into the A node of warp and feed directly into the B node. And then your alpha is going to be connected to flip distortion 2. Finally, the output of that is going to be passed to a multiply node and it's going to be multiplied by your distortion amount 2. Okay, we're almost done with the noise. Now we come down here, and here you're going to need noise scale, master noise type, and flip master noise. You don't need the distortion amount stuff for the noise itself because we're not distorting anymore. So again, you're going to take your texture coordinate, connect it to a divide node, divide it by your noise scale value, connect it to an add node, add your second layer of distortion noise to it, connect it to another add node, connect the other input of this add node to your last animation value over here, feed this into your texture-based, gradient texture-based noise and your Voronoi noise, and remember to change these from -1 to 1 to 0 to 1 for both of these final noises. So this needs to be 0 to 1, This needs to be 0 to 1. Finally, we're going to feed the outputs into another static switch. Top noise into true, bottom noise into false. Value plugs into master noise type right here, which is another static Boolean parameter. And then again, slight difference. The output of this is going into a 1 minus node rather than a multiply -1 node. We're plugging that into A, we're plugging the unaltered value into B, and then we're plugging the alpha into flip master noise parameter, which is just a scalar parameter. Finally, our output is going into a saturate node, and once we get here, we have our master like grayscale noise that we're going to use for the planet. Okay, next. We're almost done, believe it or not. This is a way simpler node than the other one. So next, you're going to want to lerp multiple float 3 value, and you're going to create 3 vector parameters, which are just color inputs, basically. Vector parameter. Color 1, color 2, color 3. Plug your color 1 into the 1 node of your lerp multiple node. Plug your color 2 into the 2 node of your lerp multiple float node. And plug the color 3 into the 3rd one. Take your noise map that we were just talking about, that's coming out of the saturate node, and plug that into the alpha. Then you're going to want to multiply the output of that by brightness, another scalar parameter called brightness. And then you're going to want to run that into a desaturation node and create a scalar parameter called desaturate and plug that into the fraction here. Finally, the output of this desaturation node gets plugged directly into the base color of your material outputs. And we're literally almost done. The only thing left, so let's take a look at what we have here. So the only thing we have left is the fact that this does not look like it's made out of gas, because the edges are solid and clean lined edges, because there's no opaque object right now. So the way we're going to accomplish that is with a Fresnel, another Fresnel node, kind of like we used on the atmosphere, but we don't need 2 Fresnel nodes like we used on the atmosphere, because we only care about masking out the outer edges, not like the inside of it, right? So let's take a look at what this Fresnel looks like with just an outer extent of 5. Take a look at this node. Oh, that's cool and all, but white is opaque and black is transparent, and I don't want my edges to be opaque. I want my inside to be opaque. So we're going to run the output of the Fresnel node into a 1 minus node. Now, there's not a lot of color variance here, so it's hard to see, but you can kind of tell it's fading out towards the outer edges, which is the purpose of our outer fall-off node here. So run the output of your 1 minus x into a power node and connect the exponent to an outer fall-off scalar parameter that has a value of like between 8 and 12 is probably fine. And so we can look at what that looks like. Okay, and now we can see that we have something that we can use as an opacity mask that's fuzzing out the edges, right? But the inside remains solid. So let's play around with this just a moment so you can kind of get a feel for what it does. 5, 6, 7, 8, 9, 10, 11, 12. I think about 8 probably fine. Now, because you're running this through a power node, usually I run it through a saturate node. I think this is basically free on graphics hardware, so usually I do it, but I think it would be fine not to do it. But anyway, so you take your output of this node, run it in a multiply by a master opacity. In case you ever want to make this more translucent than it actually is by default, we'll set this to 1 by default. And finally, you're going to want to plug that into the opacity field of your material. And the material, and that's it. For the gas giant texture, that's pretty much it. So for the material properties, you're going to want surface, translucent, default lit. You don't need two-sided. I think that was it. You don't need tangent space normal. We're not using normals on this one. I have the lighting set to volumetric directional with a 1 lighting intensity. So let's see what we ended up with here. Okay. Doesn't look like too much in the material editor because you don't, like, it's translucent. Obviously, this isn't what a planet looks like. But I actually wanted to play with this. Oh yeah, I like that. So we can actually kind of get some opacity though, like this. So let's take a look at what that looks like out in the world. I'm curious. So this might be a way to do the opacity on it without, and still have fuzzy edges without having to have the black body sphere on the inside, but you would still need it for shadows. So let's grab our gas planet and open this up. Let's play around with that master opacity field a bit. Because this is something that I should have done the first time I made it, but I just didn't think about it. So 1, 5. You still need the black body because I can see. Yeah. You're never gonna. I mean, you might be able to do it with the smooth step. The problem is we're never hitting like one complete opacity, right? I also think my atmosphere might be smaller than my actual planet. Yeah, it is. So this should be like a 15. Ah, that's why it was so... That's why I was turning the opacity all the way up, and I was like, that doesn't look right. So now we can bring this way down. There we go. Save that. So, I am curious to try something while I'm in here messing with it. If I were to do a smooth step instead, and I was to take this, plug it into the value, and take this. Capacity ceiling. That's going to make it completely hard-edged, but also completely opaque. And then I was to take this and do like 5. Let's take a look at it in the world. This might be a better way to control it than multiplying it. Because we can like programmatically set the value to 1. Yeah, so like you still can see through it. This is the problem with using it as a translucent material. Although, to be fair, it's doing a good job of blocking the stars, but it's not blocking the ring. I think you just gotta have it. It's not like you wouldn't have to have it for the shadows anyway. But yeah, so I actually think that... Go back to our gas planet texture, mess around with the value we just added in. Yeah, that's not bad. Yeah, so I think I'm comfy suggesting this instead of a multiplier. This gives you pretty fine control over the outer edge here, which I think is good. I also think our black body is too small. like you can look at it, right? So if you look at it and you eyeball it, you can see the edge if you're looking for it. So we can come in here, up this to like a 14. I think that looks pretty good. So yeah, that's it. That's how you do a gas planet texture that looks like this. Have fun. Have fun trying to build all this stuff. It took me. I basically made this over Labor Day weekend, working quite a bit on it each day. But yeah. So you know, if you like the materials, let me know. That's it for me for now. I think I'm gonna go play some Magic because I've been doing a lot of Unreal stuff, and I'm gonna play some